Nutrition science and everyday application. Healthy skepticism in nutrition science. By this point, you should understand the types of studies used in nutrition research and the quality of evidence each can provide. As you sift through studies, there are a few limitations of nutrition research that are always worth keeping in mind. Challenges in nutrition research. There are some inherent challenges to researching what people eat and how it affects their health. This fact limits the quality of evidence and stirs controversy in nutrition research. Influence of food industry funding. Because government funding for nutrition research is limited, much of it is funded by the food industry. Industry's primary goal is to sell more of their products, so they can have a conflict of interest that can result in bias in the way they design studies and interpret the results. Being alert to these two things means always examining nutrition research with a healthy sense of skepticism. Let's take a closer look at these two issues in nutrition science. Challenges in nutrition research. How does the food we eat affect our health? This question is exceedingly difficult to answer with certainty. All of us need to eat every day, but we can choose from a huge array of possible foods in different combinations. And it's probably not what we eat on any given day that matters, but what we eat over months and years and decades, our long-term eating patterns that matter to our long-term health. Imagine that you're a nutrition researcher and you've made the observation that over the last 50 years in the U.S., people have been consuming more and more processed foods made with refined ingredients and industrial processes, usually with the addition of sugar, fat, and/or salt. You hypothesize that processed foods are contributing to obesity, which has also increased over the last 50 years. You might first test your hypothesis in animal studies by feeding mice and rats a buffet of potato chips, soda, and Twinkies, and measuring changes in their body weight. You might find that the animals do, in fact, gain weight on this diet. However, you know that what is true in rodents isn't always true in humans, and you'll need to study humans in order to understand the role of processed foods in the obesity epidemic. Your next step might be to conduct an observational study, the most common type of study design in human nutrition research. For example, you might do a cross-sectional study where you compare groups of people who eat a lot of processed foods with those who eat very little. Or you might conduct a prospective cohort study in which you ask people how much processed foods they eat and then follow them over time, looking for correlations between processed food consumption and their body composition. These types of studies have been conducted and they found correlations between consumption of processed foods and obesity. For example, a cross-sectional study published in 2018 compared the consumption of processed foods and the prevalence of obesity in 19 European countries and found that countries where people ate more processed foods also have a greater prevalence of obesity. A prospective cohort study published in 2016 followed nearly 8,500 university graduates in Spain and found that those who ate more processed foods were more likely to be overweight or obese 9 years later. From these results, can we conclude that eating more processed food causes weight gain? No. It's a tempting conclusion, but this brings us to the first major problem with nutrition research. Observational studies can only show that two variables, eating processed foods and obesity, in this case, are correlated. not that one causes the other. This distinction is especially important in nutrition because diet is intertwined with many other lifestyles and socioeconomic factors that also affect health outcomes. For example, people who eat more processed food might also eat fewer fruits and vegetables, exercise or sleep less, have more stress, or have less access to preventative health care. These are just a few of the confounding factors that could explain the observed correlation between processed food consumption and weight gain. Weight gain might have nothing to do with processed food and instead be driven by one or all of these factors, or others that we haven't considered. The second major problem with observational nutrition research is that it's difficult to accurately quantify what and how much people eat, especially over long periods of time. Epidemiological studies usually rely on questionnaires that ask people to remember how much food they ate, but people are notoriously bad at remembering this type of information. And sometimes we fudge the truth. For example, you might remember that you had a cup of coffee, but forget that you added cream, completely forget about a mid-morning muffin snack, or guess that you ate 2 cups of veggies when it was closer to 1.5 cups. And many diet questionnaires, called food frequency questionnaires, ask people to recollect and mentally average their food and beverage intake for the last 12 months, not just yesterday. Questionnaires are detailed, and there's plenty of room for small errors to accumulate. A third challenge in nutrition research is that diet is just so complex. Stanford physician and researcher is a frequent critic of observational nutrition research, described the complexity of diet, saying that individuals consume thousands of chemicals in millions of possible daily combinations. For instance, there are more than 250,000 different foods and even more potentially edible items, with 300,000 edible plants alone. He also points out that how an individual responds to a particular dietary pattern can be influenced by genetics, age, and the way they metabolize nutrients. Disentangling the potential influence on health outcomes of a single dietary component from these other variables is challenging, if not impossible. Returning to the question of processed foods, all 3 of these challenges impact how we interpret observational studies that show a correlation between processed food consumption and weight gain. It doesn't mean that these studies are useless, but we want to be aware of their limitations and consider other ways to test the hypothesis. One way to overcome these challenges is to conduct a randomized controlled trial, the study design that gives us the highest quality evidence. RCTs are time and funding intensive experiments, so they're usually only conducted after consistent evidence from observational and laboratory studies have accumulated. It turns out that there has been a randomized controlled trial of processed foods and weight gain. In this study, 20 participants lived in a clinical center for 1 month where they consumed only processed foods for 2 weeks and only unprocessed foods for another 2 weeks, and they could eat as much or as little as they liked during these periods. The diets were carefully designed by dietitians so that they were matched in calories, sugar, fat, fiber, and macronutrients, and the exact amounts consumed by the participants were measured every day. The study found that people ate about 500 kilocalories more and gained about a pound per week when they were eating processed foods. This study design could show causation, not just correlation, because the other nutritional factors like calories, sugar, fat, fiber, and macronutrients were held constant, and the diets were tested in the same people, so other factors such as genetics, sleep, stress, and exercise were constant between the two types of diets. This was an example of a crossover randomized controlled trial in which each subject serves as their own control, and they completed the processed and unprocessed phases of the trial in random order.